Namaskar and hello everyone. I hope all of you are having a good time. So, this is the fourth lecture in the series Motion in a Straight Line. Today we will study uniform motion in a straight line. So, this diagram I have copied from your note directly, okay, which I have already provided you. Now you see we have this OX axis. OX is an axis where O is the origin and X is along a certain direction. We have placed here time t equal to 0, t equal to t1, t equal to t2. A, B, C are 3 points. Okay, so say OA is x0, OA distance is x0, OB distance is x1 and OC distance is x2. Say, say you fix the origin at your home. You fix the origin at your home. Your home is the origin of this situation. A is a marketplace near your home. Say it is at a distance of 1 kilometer from your home. In that case, your OA, which is x0, which we have marked with x0, is 1 kilometer, say. Now B is your school. B is your school. So in that case, your say OB, say your school, which is x1. Okay, say your school is at a distance of say 3 kilometer from your home. And C, consider C as a river. Okay, and in that case, like OC, which we marked as x2 in the diagram, is say 5 kilometer. Okay, so the river is at a distance of 5 kilometer from your home. Now AB is this particular length. So if you have OA as 1 kilometer and OB as 3 kilometer, then AB is 2 kilometer. That is pretty obvious, right? And similarly we find out BC. So if x1, what is the value of x1? X1 is 3 kilometer. Okay, and if x2 is 5 kilometer, then 5 minus 3 gets you 2 kilometer again. Okay, now the body, or say you are boarding a vehicle. Okay, you're boarding a car and the car is traveling with a constant speed of say 50 kilometer per hour. So when you say the car is traveling with a speed of 50 kilometer per hour, you are also saying that it is having a uniform motion. Okay, and when we say 50 kilometer per hour as the velocity, say if I put the vector sign here, okay, so that means you are going along the same direction, you are not changing direction, and your speed is constant throughout the journey. Okay, so now the situation is we are not starting the journey from the origin. That means you are not starting the journey from your home, rather you are starting the journey from the school. So the event will be measured. The event in this case will be measured from the marketplace when you started the journey, and therefore this particular time will be measured as 0. Okay, say you reached your school in 10 minutes, then T1 would be 10 minutes. Say you reach the river by measuring from your from the market in 20 minutes, then T2 would be 20 minutes. Okay, T1 is 10 minutes, T2 is 20 minutes, and T is 0. Okay, so I hope this point is clear. Now regarding the journey, when you would like to start it from your home, that will be included in the special case. You can just look into towards the end of this derivation or end of this topic. Now say here OA is how much? I'm rewriting again. OA is x0. Okay, OB is how much? OB is x1, right? OC is x2. Now AB will be what? What will be this distance AB, which we marked as 2 kilometer here? Now you see the body is traveling, or the car is traveling with a constant speed, right? The car is having a constant speed. So in this length, along this length also, the car was traveling with 50 km per hour. Here also the car was traveling with 50 km per hour, and here also. That means throughout the entire journey. So in that case, you can say that if v, velocity, is equal to displacement by time, or speed equals to distance by time, then s will be given by v into t, right? So what is the time interval, or what is the time between the points A and B? The time interval would be t1 minus 0. Okay, so you can say, or we will say, that at t1 the body is at B. That means the distance AB is v into t1. Okay, because for t1 time the car was traveling with a speed v, therefore the distance is v into t1. The speed into time will get you, speed into this particular time will get you the distance AB. Okay, similarly, if you want the distance AC now, okay, AC, here the car was traveling this distance AC with speed v, and what is the time? The time taken is t2. So therefore, like, your AC would be vt2 here. I hope this is clear. So if you have understood this, so we can write down OB. So if you look at the length OB here, OB is this, right? So OB can be written as OA plus AB. Can we write? Yes. So OB can be written as OA plus AB. So what is OB? Just take down the value from here. OB is x1. What is OA? OA is x0. What is AB? AB is vt1. Let this be equation number 1. Okay. Now, if I ask you like OC, how can you write down the, how can you fragment the length OC? Okay, so we can write down OC as OA plus AC, right? So OA plus AC. So what is OC now? OC is x2. Yes, OC is x2. What is OA? It is x0. And what is AC? AC is vt2, right? So OC is x2 equals, what is OA? OA is x0 plus AC is vt2. Let this be equation number 2. So what does this equation tell us? Like equation 1 and equation 2. Equation 1 gives the position of the object at time t equal to t1. Okay, that means it is telling you about x1, right? What is x1? X1 is the position of the object at time, or the car at time t equal to t1. Equation 2 is talking about x2. That means it is talking about this, right? It is giving you the information about the position of the car at time t equal to t2, right? Now if you subtract like 2 minus 1, what do you get? 2 minus 1. So on the left side you have x2 minus x1. On the right side, x0 will cancel, and you will have vt2 minus vt1, where if you take v common, you will get vt2 minus t1. Okay, so like this is x2 minus x1 equals to vt2 minus t1. So let this be equation number 3. So what information does equation number 3 gives you? Equation number 3 give you, it tells you about the displacement during the time interval t2 minus t1. So x2 minus x1, you see, x2 minus x1, that means it is talking about this BC length. So what is the displacement of the object? What is the displacement of the object during the time interval t2 minus t1? It is BC, right? So BC can also be written as x2 minus x1. So that information is being given by equation number 3. Now we can write down, from this equation we can write down x2 equals to x1 plus v t2 minus t1, and this is your equation number 4. So what information does equation number 4 give you? Equation number 4 tells you about the position x2. in the time interval t2 minus t1. Okay, so these are the information that you get from these four equations, and these four equations are the equation for uniform motion. Okay, these are the formulas for uniform motion. So equation 1 to 4 are the formulas for uniform motion. Mind it, you have to correlate this lecture with the notes that is provided via WhatsApp groups. Okay, otherwise you won't be able to understand my handwriting. Here I speak and my handwriting is not very clear, or it's not very good. You have to correlate and study. So we have so a point which is to be noted is, now in the same situation, in the same diagram, if you consider the motion to be happening right from the origin, that is right from your home. Okay, so what were the equations of motion that we have written, that we have figured out so far? I'll rewrite them for your convenience. x1 equals to x0 plus vt1, that was number 1. x2 equals to x0 plus vt2, that was equation number 2. x2 minus x1 equals to vt2 minus t1, that was equation number 3. And x2 equals to x1 plus vt2 minus t1, that was equation number 4. Now you see, if you started the journey, if the event is started right from your home, right from the origin, in that case this x0 value would become 0, right? So if the motion is considered from the origin, then x0 will be 0, right? So if x0 is 0, then you see equation 1 would become like x1 equal to vt1. Equation 2 would become x2 equals to vt2. Equation 3 would become x2 minus x1 equals to vt2 minus t1, right? And equation 4 would become x2 equals to x1 plus vt2 minus t1. So when the motion starts from the origin, your equations for uniform motion, the formulas for uniform motion, will be these four equations. Okay, I hope things are clear till here. We'll move to the next topic, which will be a graphical study for uniform motion. I'll just copy the heading to save time, the title. And this particular graph. So now we saw two equations, right? When the journey started from the origin, when the event started from the origin, the equation was x equals to vt. Okay, from origin, when the event started from origin. And we had another equation, which is x equals to x0 plus vt. X0 plus vt when the event started from some location x0, from location x0, okay. Now you see slope. I hope you studied about slope in high school in coordinate geometry. So slope of, this is displacement time curve, okay, xt graph. xt graph. Slope of xt graph. Now, how do you write down slope? Like slope is denoted, you see, slope is denoted by m, small m, and the measurement is determined by finding out tan of the angle, okay, tangent of the angle. So tan theta is perpendicular by base, right? So if you consider this as a triangle, like yeah, say this is a triangle, okay, if you consider this as a triangle, like if I put another name like OAC, what is the perpendicular here? The perpendicular is this. What is the base? The base is this. Okay, so how inclined a particular surface is always measured by the ratio of the perpendicular and base. Okay, so here like AC by OC will get you the slope. Okay, now what is this AC? AC will have a certain value for displacement, since you have this displacement along the y-axis. So AC will have a certain value for displacement and OC will have a certain value for time. So we are not going into the values right now, rather we are writing down x by time, displacement by time straight away, right? Now what is displacement divided by time? That will give us velocity, right? So you can put a vector sign or you can leave that, because we are dealing with motion in a straight line. So speed and velocity will indicate the same thing, since direction is never changed. Okay, so when you say that a body is traveling with a constant velocity, or a body is traveling in a straight line, then its velocity and its speed will remain the same. Okay, if the body is changing directions, then speed could be constant, but velocity will not be constant because it is changing direction. Anyway, those things were discussed in the previous class. So what do you understand from this particular graph? You understand that slope tells you about velocity. Slope gives you information about velocity. Okay, so m is the slope and m is equal to v. Okay, so now you see, if this is theta, if angle AOC in the graph is theta, now more is this angle, because you know the value of tan keeps on increasing with the value of theta, right? Tan 0 is 0 and tan 90 is infinity, right? So if say now in this particular case, okay, we'll come to that a while later, sometime later. In this particular case, it is pretty obvious from the graph that both these curves are parallel to each other. Okay, so if they are parallel to each other, their the theta inclination with respect to the time axis or the x-axis, in this case, this theta and this theta, they are equal, right? So if the graphs are parallel, or in other words, you can also say it as, or if the slopes are equal, then b is equal for both of them. Okay, so here like body B was traveling with a speed v1 and body A was traveling with a speed v2. So here v1 and v2 are equal, and they are, you can take them as v common, okay, as a common quantity v. So what you are understanding is that, like here, if v1 is 30 is say if body B is traveling with a speed 30 km per hour, then body A is also traveling with a speed 30 km per hour, and the entire motion, both of these bodies are traveling along the same direction. Okay, since they are in the first quadrant. Now it gives you one more information. The other information is, at time t equal to 0, body A started the journey. Okay, car A started moving, but car B started moving, of course at time t equal to 0, but from a different position. Say it is ahead of body A by some by some length x naught or by some distance x naught. Say if we relate this with the previous situation that we have studied a while back, say you started the journey along the x-axis or along a straight line at time t equal to 0 from your home, and your friend B started the journey along the same direction but from the marketplace. I'm relating to the previous example. So you two are starting the journey from two different positions, but you are starting the journey at the same time, okay, because for both of you the time is 0 when you are starting the journey, and since your slopes are equal, therefore your velocities are equal, okay, or in other words, since both the curves are parallel, therefore the velocities are equal, and since they are lying in the first quadrant, therefore it is happening along the same direction, the motion is happening along the same direction, okay. So this is the information that you get from this particular graph. Now we see the second situation, which is about object at rest. Object at rest. I'll just copy the figure from here. So you can see here at time t equal to 0, this particular curve or this particular graph, if you name it as say A and if you name it as B, body A, time is progressing, okay, time is progressing gradually, but along the y-axis, which is displacement in the present case, this A is not progressing along the y-axis. So you can say that body A is at the origin, okay, it is sitting at the origin, all right. With the progress of time, body A is not changing its position, so body A is at rest. Body B is also at rest, but at a different position. Say again, if we relate to the previous example, say your friend is waiting at the market, okay. So with the progress of time, he's sitting in a certain place and he's not changing his position. So his position was x naught at time t equal to 0, and at time t equal to 5 seconds, it is still x naught. Therefore your friend is sitting in the market and you are sitting at home, okay. So this is the graphical situation of an object at rest. So the other way you can look into this problem is by saying that slope of A and slope of B are equal and they are 0. So when slope is 0, so velocity is 0, right? Because slope is equal to velocity. All right. So we have this third situation. The third situation. We have combined many things here. So uniform so it will be a uniform or constant velocity, okay. So uniform or constant velocity. So here in this particular curve you have say 4 vehicles A, B, C and D. So this is the curve of body A or car A, this is for B, this is for C and this is for D. So it is pretty obvious that C is at rest, okay, by the previous understanding you can say that. And body A or car A has maximum theta, right, or maximum slope, followed by B, right. C has 0 slope and D has a negative slope, okay. So what do you understand by that? Now know that time is always positive, right? Time cannot be negative. So all motions will happen or the graphical presentation will happen in the first quadrant or the fourth quadrant. thereby keeping time always positive. You cannot have a graph along the second or the third quadrant, because that will indicate you have taken the time as negative. So since time is positive, you have to stick to positive time. Now if you have a graph in the first quadrant, it will indicate that displacement is positive, therefore it is say along the positive x-axis. Okay. Now if you have a graph in the fourth quadrant, it will indicate that displacement is negative. इसका ये मतलब हुआ कि if in the first case if you are going along east, then in the fourth quadrant case, say in the case of D, you are going along west, and this will be exactly diametrically opposite direction. Okay, like 180-degree opposite to the previous case. So here, like slope m1 is greater than m2, it is greater than m3. However, about slope, about the fourth slope, it is not pretty clear whether it is equal to slope b or not. Okay, so we'll just exclude that from this point of discussion. We'll include that in the examples. Anyway, I'll just show you one example, and the other graphs will be given as homework. So if we decide between A and B, now slope for the first body or the first car, A is greater, therefore you can say that speed v1 is greater than v2, although individually they are constant speeds. It is like if v1 is maintaining a speed of 30 km per hour, then v2 will maintain a speed of 20 km per hour, and that will stay constant all through the journey. Now v3 is equal to 0 because as slope is 0, and v4, this is velocity, right, is negative. This tells you that v4 equal to negative tells that D is traveling in a direction opposite to A and B. I hope this is clear. Like A and B are traveling along the same direction with different speeds, of course, and individually those speeds are constant speeds. Okay, so A is having a greater speed followed by B. C is at rest because the slope is 0, right? And D is traveling in a direction diametrically opposite to that of A and B. Okay, now whatever speed, like if you have one more body E, so E is also traveling in a direction opposite to A and B, diametrically opposite to A and B, but E will have greater speed in comparison to D, because the slope of E, okay, will be greater in comparison to the slope of D. I hope this is clear. Okay, and an interesting example is given over there. Okay, one more point. This point is to be included. Now, as A and B are traveling with constant speed in this situation, okay, A and B individually they are traveling with constant speed. Although, again, I am saying कि V1 and V2 are different. Like this could be 30 and this could be 20, but they will sustainably it will be 30 and 20. Okay, so in that case, your ratio V1 by V2 will always be a constant. All right. So you take the ratio at time t equal to 5 seconds, 10 seconds, 15 seconds, it will always remain constant. Okay, so an example is shown over here. Body A could be moving with 300 km per hour along the entire journey of 1 hour, and body B could be traveling with 400 km per hour for the same duration in the same straight path or direction. Okay, so in this case both have constant speeds, right? Individually they are constant speeds, but they are not equal to each other. Okay, so their slopes will be different, as in this case in the same graph you can consider, like body A will have greater slope, body B will have lesser slope, right? So I often take I often try to take the discussion of physics beyond the classroom or outside the classroom. Here I have used two velocity numbers or two speed values, like 300 kmph and 400 kmph. So Okay, did I say like body A is traveling with lesser speed and B is traveling with greater speed, right? So in that case, okay, this should be, or let me put that as, let me make a correction here. Body A, let me give a greater speed for body A 400, otherwise it will not agree with the graph. And body B is 300. So body B is this and A is this. Okay. So body A is moving with 400 kmph and body B is moving with 300 kmph. Okay. So here body A has greater slope in comparison to body B. I hope you can relate that. Now body B could be MB Augusta Brutale 1000 RR. Okay, this is one of the, this is a super bike actually, and the body A could be Kawasaki Ninja H2R. You can Google all this for your interest. Okay, so this is the fastest motorcycle on earth right now. All right, this can travel with a speed of 400 km per hour. Okay, so if you are interested in these stuffs, like this is like taking the discussion or relating the classroom stuff with the outside world, you can Google for more information. Now we come to velocity time graph for uniform motion. So we have seen these two equations, x equal to vt when the journey started from the origin, and x equal to x naught plus vt when the journey started from a position x naught. Okay, now if you differentiate, okay, like x with respect to time, okay, let's see this topic, what will happen. Let me copy the diagram as well. Or the graph as well, I should say. So we have covered this equation, x equal to vt when the event is started from the origin. Now if we differentiate x with respect to time, ddt of x, so v is a constant, right? So ddt of x means ddt of, we are differentiating with respect to time, ddt of vt. So v taken common, it gives you ddt of t. So ddt of t is 1. So v into 1, that is v. Okay. So v is a constant. You already know because this is the case of uniform motion. And if we differentiate the other equation like x equal to x naught plus vt, if you do it like dx by dt, then you get ddt of x naught plus vt. So ddt of x naught is 0, yes, because x naught is a fixed distance, right? If you recall the previous diagram. So 0 plus, and ddt of vt will get you v, so this also gives you v. Okay, x naught is constant. Now in this particular graph, you see whatever value you have on this point, at time t equal to 0, the velocity or the speed is say 30 km per hour. Say this is 30. All right, at time t equal to 1 second, say if it is 1 second, it is still 30. It is not progressing along the vertical axis, right? At time t equal to 2 seconds, it is still 30. Okay, so all you can say is the body is having a constant speed. Okay, now this is along a certain direction, say along the positive x-axis it is happening, since it is the first quadrant. Now you are having the other graph in the fourth quadrant. Now here the velocity is minus 30. It is only telling you that it is also traveling with the same speed but in the diametrically opposite direction. Like you are going from point A to point B initially, like plus 30 km per hour is the velocity. In the second case, you are going from B to point A, okay, with the same speed, that is 30 km per hour. All right. So this should be clear. Now, displacement of an object during the time, you go through this statement. Displacement of an object during the time interval t2 minus t1 is always equal to the area under the vt graph. Now this is a velocity time graph, right? So this is the velocity showing constant velocity, right? So if we consider two time intervals or two times like t1 and t2, and if you want to find out the displacement of the car in this time interval, then what you have to do is that you have to find out the area of this space right under the vt graph. Okay, say you need the displacement in between this time interval, so we will be considering this particular area. So what is the area of this shape or of this square or rectangle, whatever you say? This side length is v because this is the velocity, and this side length will be of time, and because this is the time axis, right? So the time would be t2 minus t1. Okay, so let me copy this figure, this graph. So here if I just write down area under the vt graph, okay, that is area of ABCD, because we are considering the time interval t2 minus t1. Okay, so that will be like one side v, the other side is t2 minus t1. So this will give you the displacement of the object during t2 minus t1 time interval. All right, so this should be pretty clear. Now we have two important points to be noted for vt graph. The first point is that, okay, I'll explain that with the help of a graph. The first point is that you have a graph and you have this first quadrant and fourth quadrant, right? Like this is say positive v and say this is negative v, right? So while calculating net displacement, you have to consider both of these areas, right? Say you are considering between two time intervals t1 and t2, so you have to consider both of these areas. Now you have to take care that this particular area will be considered as positive and this particular area will be considered as negative. So if both the areas are same, the net velocity or net displacement would be 0, because this is positive and this is negative. That is what you do in case of displacement. Okay, now we see one more situation. What do you do in case you have to calculate the distance traveled, okay, or net distance traveled? So in that case, this negative area will be considered as positive, right? Because distance can never be negative. So you calculate this area and you calculate this area and you directly add them. All right, like both the positive values, both should be positive. This will be positive value, but this negative area will also be considered as positive, and you'll add them to get the total displacement. I hope this clears this particular concept. Okay, so after this you have some note for uniform motion, and this should be pretty obvious, like after you go through the entire lecture that has been said so far, that has been delivered so far. So you can go through these points, and if you do not understand, we can interact. Now there are some homework problems. Write the information that you get from the graphs. Okay, so in the first graph ABC, you can consider them as three vehicles. Okay, so what information do you get, like about from their slopes, about the speed, about the direction? All right, if one speed is greater than the other, you just need to write them in brief. That will stay as homework. I'll just provide you the solution before tomorrow's class. Okay, say I have done one particular example for you, although it was done previously. So here in both these graphs you can see that slope of these graphs are equal since they are parallel lines, so their slopes are equal. Okay, so, or in other words, you can also say they are parallel lines, therefore they have the same velocity. Both the bodies are having the same velocity, that is same speed and same direction. Of course it has to be same direction because they are lying in the first quadrant, the same quadrant, right? And since they are parallel, they have the same velocity or the same speed. Okay, so I hope you'll be able to do the other questions also. And this is what we have from today's class. Thank you.